Yeah, so thank you, Adilaja. I said good evening. Who else do we have there? Anyone who wants to say good evening to the house, you could just mute and then say good evening and tell us your name, your university, if you are still in school.
Why is it chat, please?
Okay, the chat. Okay. So let's use the chat for that. All right. Okay.
No,
So
I sent a chat, yeah.
thank you. So Mr. Bisiga is ready now. Mr. Bisiga, say hi to everyone.
Hi everyone, can you hear me?
Yeah, it's loud and clear. Thank you. Welcome, Abisiga. You're looking good, man.
Yeah, thank you very much.
Yeah. So
Uh,
welcome. Yeah.
Thanks so
Yep.
much for this opportunity. Yeah, I'm glad to be here to share the little I know about data analytics. It's a privilege for me,
Oh,
actually. Thank you very
Mr.
much.
All right, you're welcome. Your face speaks a lot of data already. I can capture so many data from your face already. Yeah, I'm sure you want to drop them every this evening. Yeah, so welcome. We are so excited to have you. Yeah, so welcome. So we are starting right away. 5 o'clock on the dot. You have the floor, Mr. Abisiga. So yeah, everyone get your writing materials close to you. We are hearing stuff on data analytics for those that want to get into that space. Data analytics, data science. So prepare your mind, prepare your questions. We have a data engineer here in the house. So yeah. So Mr. Abisiga, let's start right away. You have the floor, please. Thank you. Welcome once again.
Yeah, thank you. Yeah, so let me share my screen. Think. Yeah, so firstly, okay, I think he has introduced me already. So basically what I do is data, like basically solving complex business problems for companies. And I've done this in like by assuming different roles, either as a machine learning engineer or automating processes, basically RPA, or maybe focusing on the aspect that has to do with working with software developers, which is basically machine learning engineering. Uh, yeah, so I so I've also been like opportune to build visualizations too, like during my previous roles. So and currently I'm a student. Yeah, so we have actually learned some more things that I knew than more things than what I knew before. And I think, yeah. So basically, I'm here to talk about data analytics and how we can make use of data analytics to solve real world problems. And what I'll be talking about is basically explaining what data analytics is about, the skills that are needed, and the available opportunities in this field. Yeah. So firstly, I'll like to start with data. Like basically this is about data analytics, so we need to first talk about what data is, and like why there's always this buzzword around data and data analytics and everything. So like everyone says that like currently data is the new oil. Actually, they used to say oil was, what did they mean by that? They said by the economist says that the world's most valuable resource is no longer oil but data. And what do they mean by that? Previously, oil used to be the most valuable asset. Actually, when you look at the top 5 companies that in terms of revenue and in terms of money they make from the businesses they run, like that in about, like, I think in the year 2006, I think the top 5 companies or 6 companies consisted of mostly energy companies, companies that has to do with oil and generation of energy. Companies like maybe companies like Shell, companies like General Electric, companies like I think maybe Total, and yeah, mostly BP, British Petroleum, those were the companies that were
Saudi
topping.
Aramco.
Sorry, can you hear me?
Yeah, Saudi Aramco.
Yeah. So basically, those companies, those oil companies were the ones leading in terms of revenue. Yeah. So, but now, like since 2016, basically, you can see that most of the companies that like are leading in terms of revenue, or that even the people that are the richest in the world, the kind of companies they run are companies that have to that run based on data, companies that are data centric. So you can look at the likes of, I think they call them FAMGA. At some point it was called FANG or something. So you can see Amazon basically they deal with, delivery of services, like where people can basically purchase what they want online and get it within some business days. And basically I think there's one kind of model that Amazon has currently put in place in terms of delivering services, delivering people's goods to them. They call it I've forgotten what they call it actually. So what they do is that they try to reduce the time it takes to for all these goods and services, that goods that people order for online, by predicting, based on people's purchase patterns. They can predict, the likely goods they will most likely purchase, maybe within a period of time. And if they're able to predict that, they're able to move those goods to the nearest location, such that once those customers actually purchase them, they can easily move it to them, or they can easily ship it to them, because they've already predicted that these guys are going to buy stuff like this within a like in a particular period of time. Then also Google, we all know that they have all the data, like they have all the data. People, Facebook, they have all our social media data, what people are saying online, the comments, the likes, what people share online, even Uber, information about where we are, the traffic, I think based on sensors and everything, they're able to like use that to, you know, try to reduce traffic based on people's locations and everything. Google in particular, they have a lot of data. I think I saw one joke online when they said that, like, if you want to apply to Google, you don't actually need to upload any of your information. You don't need to apply. Like, they already have all your information. They don't need your CV. And of recent, I think that was like a month ago, I think a recruiter from Google reached out to me, and on responding to him and booking an appointment with him, suddenly I just received a mail that's like, you have successfully applied for so role. And I didn't share any of my information. And the day we had a conversation, I was like, this guy is reading my CV. Like, I don't know. Probably I'm just the one imagining all those things, but I didn't share any of my information with him. I was shocked actually. So there are a lot of, data is the one bringing in money for a lot of all these big organizations now. And, this has actually led to some issues. Like, people feel that these companies, they have too much of this our data. Like, are we safe? What are they using our data for? Are you sure they are not using it, for bad reasons? I think I'll go when, like, at a later point in time, I'll talk about the great hack. So, like, you can see, like, from 2010, the data, this volume of data available on Earth has actually been increasing. I think at an exponential rate. I think from the beginning of maybe when from beginning of when they started counting the years to like the beginning of dawn of civilization, I think we generated about I think 1 exabyte of data or so. But all the data that we generated from then to like the beginning of dawn of civilization, we are now generating all such kind of data like in every 2 days now. Like, you can see that it's actually increasing at an exponential rate. You can see Google processes about 3.5 billion search queries. Instagram use like 54,000 photos. They post about 50. Yes, people post a lot on social media, on IG. And also all these autonomous vehicles, they generate like 11 terabytes of data. They have a lot of sensors like that transmits, I think maybe if you've heard of the Internet of Things, some of all these devices, they have sensors that communicate with one another, and they send information to a central system. So like that's where all these 11 terabyte of data are being generated. Then also Twitter, a lot of people use Twitter to post a lot of tweets, and you can see how viral all these things go within just a split second. It's not just about like high volume of data, it's about the speed at which it comes to. And because of this, before we used to like before we used to have issues with getting data. There are just few companies that generate data, while all other companies try to get the data either by buying it just to use for their purpose of whatever purpose they want to use it for. But now, like every company, like all devices are generating data now to the extent that we even have more data than like we can use. Now we want to find a way to use everything. Like the data is just too much than we can process, or than what we need it for. So that moves me to the great arc. So I'm going to play a YouTube video. So like this is basically going to explain, like how data moves around, and maybe the possibility of them this data being used used for a negative purpose or something.
Seen an advertisement that has convinced you that your microphone is listening to...
Sorry, can we hear the audio? Can
Yes,
anyone hear
you can. Yes.
Okay. Yeah, thank you.
To your conversations. Who has seen an advertisement that has convinced you that your microphone is listening to your conversations? All of your interactions, your credit card swipes, web searches, locations, likes, they're all collected in real time into $1 trillion a year industry.
The real game changer was Cambridge Analytica. They worked for the Trump campaign and for the Brexit campaign. They started using information warfare.
Cambridge Analytica claimed to have 5,000 data points on every American voter.
I started tracking down all these Cambridge Analytica ex-employees.
Someone else that you should be calling to committee is Brittany Kaiser.
Brittany Kaiser, once a key player inside Cambridge Analytica, casting herself as a whistleblower.
The reason why Google, Facebook are the most powerful companies in the world is because last year data surpassed oil in value. Data is the most valuable asset on Earth.
We targeted those whose minds we thought we could change until they saw the world the way we wanted them to.
I do know that their targeting tool was considered a weapon.
There is a possibility that the American public have been experimented on.
This is becoming a criminal matter. When people see the extent of the surveillance, I think they're going to be shocked.
And I still fear for your life.
Yeah,
With the powerful people that are involved.
but I can't keep quiet just because it'll make powerful people mad.
States' rights should be considered just fundamental rights.
This is about the integrity of our democracy. These platforms which were created to connect us have now been weaponized. It's impossible to know what is what because nothing is what it seems.
So basically what they are trying to explain in the video is that, like there are a lot of activities that we like, a lot of things that we do every day that generates data, and some of these things we don't know that these things are being stored, and like and many of them are being used for negative purposes. For example, if you open Facebook now, some ads or some things might pop up, and let's say, for example, they might show you that, click on this to see maybe a picture of you in a frame or something like that. You might feel so excited to click that thing, and whereas they're getting information about you, things about, for example, this Cambridge Analytica, from what they said, is like they try to work with the I think the party in charge of Trump's election, and they try to make use of people's information. They had a lot of information about American citizens, and they try to make use of those information to target like the ones that they feel they can change their mind about the candidate to vote for and stuff like that. They try to send information to them, or try to send some targeted stuff to them in such a way that they will feel scared, or they will feel so just basically to change their mind towards the kind of candidate they are going to select. And that's somehow evil. Like, they are not supposed to have such kind of information, or they are not supposed to be able to use it in such a way. So these ordinary Cambridge Analytica, not to talk of people that have almost everything, people like Google and Facebook and the likes. So what basically is analytics? So analytics is basically the process of transforming data into insights for the purpose of making better decisions. So, and this could come in different ways. So, for example, in a bank, the bank might decide to make use of the information about their customers to predict which of their customers are going to like stop making use of their bank services again, or probably even telecoms too. They make use of data analytics. For example, they could predict maybe customers that won't maybe dial ports to a different telecoms provider, and that's why they send some targeted messages to you people, like to us, or for you to get double so, like maybe you want get 500% on your recharge on XYZ. All those messages are targeted, and it's based on people in that bucket. They're going to send it to similar kind of people. They have messages they send to different kind of people. So let's say they believe that these people are going to live within the next maybe 1 month, and these are the kind of things they could send to these guys to be able to make them want to purchase, or these are the things they can afford, or something like that. So they'll send it to the same. It's not the same message not everybody receives this message, just some specific set of people in a bucket, basically. And like data analytics can be applied to almost any field. Like, think of it, can be applied to almost any field. This can be applied to I'm going to give an example in like HR. It can also be used like to, for example, evaluate people's CVs. There's all these applications that we're submitting online. We talk about AI, evaluating our CVs based on keywords that we specify in the CVs and everything. All those things are natural language processing. Even, for example, Google search, some of the things we like search on Google, if we type some words, we'll see that we get some autocompletes and stuff like that. You see that it starts suggesting things for you. All those things are analytics. So what exactly does a data analyst do, or like a data scientist do in particular? So this is like a short video to. Sorry, I'm using videos. Like, I think the best describe it. That's why.
Your career to data analysis. Act now before prices increase and save $5,500.
If you're curious what a data analyst or data scientist does on a day-to-day basis, this is the video for you. I've spent day-to-day work in data analysis jobs consists of 3 major things: process, data, and math. Now, there's lots of other details that go into the day-to-day work of this job or any other job, but these are the 3 core pieces that are going to take up 95 to 99% of your job. So let's look at each of them. Process. When I'm talking about process, I'm not just talking about the data analysis process, but I'm talking about the overall problem-solving process. Your real value to a company as a data analyst is being able to take a problem or a wanted outcome and figure out how to get from here to there. It's really kind of like a math proof where you're taking all of the things that you do know to find the answer to something that you don't know and explain something that you don't know. So the process involves all of the information gathering from the stakeholders that are presenting you with a problem that needs solved, to investigating what the real desired outcome is, not just what the question being asked is. All of these pieces go into that process. So this is probably going to involve meetings, whether it's one-on-one or in groups. It's going to be calling and talking to different people. This process piece also is going to be some amount of research looking for if this has been addressed before or other pieces of information you might need as inputs. Now, the process piece is a lot of times mostly on the front end, but there's a piece that happens on the back end as well. And that's how you communicate your analysis and results back to the people that need it or to the people that are going to make some sort of decision or take an action off of it. So within that process, it's how do you visualize the data? How do you communicate in whatever form necessary, whether it's written or in person, you need to be able to communicate well. And that's also part of that data process, that process step for an analyst. So on this process step, expect to spend about 20 to 30% of your time on this. In some cases, you may spend even longer. There's such a critical piece of the work that's about understanding what the problem really is and all of the necessary things that influence it to be able to make sure that the answer you provide is correct, and then providing that answer at the end of your analysis work. Once the problem is clear, you can move on to the data step of the work. So data is where you're going to spend probably 50 to 80% of your time. And this consists of three major things. It's gathering the data, cleaning the data, and processing the data. So depending on the problem you're working on and the company you're working at or with, the gathering the data may already be done for you for the most part. You may have easily accessible databases to go get all the information you need. In other cases, you might have to do this yourself. You might have to go to different stakeholders or go online and gather some market information to use as inputs to your analysis. Then you'll clean the data. So this is going through, it's understanding it. It's also making corrections where needed, removing outliers or things that shouldn't be included in the analysis. This can take a lot of time, but understanding all of this is really necessary before you start processing it. So then the third step, processing the data. So this is actually going through and doing programming or using the different data tools that you have available to analyze the work. So again, most of your work as an analyst day to day is going to be spent on this part of the step. Then lastly is math. A lot of people go into analyst roles because they really like math. And that was the case for me as well. I really like math, but what I really like is the logic side. And so what I found is I really like data analyst work and the day-to-day activity, but most analysts don't do that much math. There's certainly math involved and mathematical principles involved in the day-to-day life of a data analyst, but a lot of the work is really more about the data and the process, and the math is maybe 10% of the actual work. Because your bigger challenge is to figure out how to solve the problem and then apply a little bit of math to solve the problem. And then you may also be setting things up so that it's repeatable. But this math step, while those skills are extremely useful, is going to be the smallest part of most data analyst jobs. So do you have a better idea what a data analyst job consists of? If you work as an analyst today, I'm curious how the split at your job looks like. Is it
Yeah, so basically, I think she said a lot about, what exactly like a data analyst does on a like daily basis. But I think I would like to add the fact that, she said, data analysts do little of maths. I think it varies for the role actually, because, uh, there are a lot of variants or a lot of, roles when it comes to data analytics. Some of them do more math than the other ones. So for example, let's say research scientists now, like research scientists, they do a lot of maths, and they try to create maybe machine learning engineers, they try to create algorithms from scratch, and they, for example, writing all these neural network codes, and developing new algorithms involves a lot of probability, a lot of stochastics, a lot of statistics and stuff like that. So I think it depends on the role. For basically a data analyst, you might not need too much of maths. It could just be in form of like Excel. Maybe you're using an Excel to analyze data, just to make to provide insights for maybe C-level executives, for them to be able to make decisions. It might not be as deep as building models from scratch. Then also, I think aside just building models or cleaning data, or maybe gathering data, I think one part that is not always talked about is the communication aspect, like communicating the insights or whatever insights you get from your data. And I think it goes in different, it has like, there are various things that are needed for you to be able to do that. You must be able to build like effective visualizations. A lot of visualization is another topic, is a topic for another day. Some people just build visualizations without like they just build charts that don't communicate anything to the audience. Like a lot of, they have to like be able to read people's mind. They have to be able to like use colors that make sense. They have to be able to like build stories. Like they have to be able to build visualizations that tell stories to the audience, and that will even make meaning. It's not just about building charts and building dashboard. Then also like the way you communicate it to them, like yeah, it has to tell a story. They have to be able to relate to it. It has to communicate with like their mind. It has to be domain specific too. So I think that's another important part that people don't really always talk about. Then I think there are different analytics involve several aspects. So it could be in form of like a static report or interactive dashboard. Basically, they use queries, like they query a lot of DBs to get data, and then provide it as a form of static dashboard. Basically, they call that one business intelligence. Then there's descriptive analytics. Basically, you're trying to know maybe what happened. Yeah, so for example, like I said, describe the past status of domain of interest using varieties of tools through techniques such as, basically you're trying to know what happened in particular. So for example, let's say in an area there was crime, like police wants to know why there was crime. So like they want to know what happened in a particular in a particular place. Let's say how many, hello?
I'm sorry, you can go
Does
ahead.
someone want to say anything? Okay, yeah. So then predictive analytics is basically you trying to predict, trying to know what will happen, or yeah, you want to know what will happen like in the future or something. You're making use of past like data, historical records to know what will happen in the nearest future. And it normally involves maybe some form of statistical models, like computational models. Then prescriptive is just you trying to know like, oh, if I do this, what will be the results? Like you're basically trying to recommend, and you will do this by trying to simulate the results. Oh, like you cannot just say that this is what will happen. You want to see, you want to simulate, you want to try to simulate maybe similar kind of scenario to see if that's the result you eventually get. Then you have I think you also have the cognitive analytics part. Basically, try the computer trying to imitate human minds and try to trying to act on our behalf. For example, I think self-driving car might be an example of that, or maybe Apple's Siri. Like, for example, in self-driving cars, like, the car knows, like it drives itself, it tries to imitate human mind, that, oh, go like this, go like that. And it's basically based on data. Then big data analytics, basically focus on, trying to get meaningful insights from unstructured data, not just, basically traditional data is just structured in form of CSV, or maybe Excel file, or maybe in a database. But big data analytics focus on all this data that is stored in like large silos, heavy data, like big, very data that is actually coming in, like coming in bulk, and also like with speed. So sure. Yeah, so analytics can actually be applied to a lot of fields, like so many fields, but this is just an example. After this, I'll just talk about some of my personal, like, let me just play. I think this is the last video.
In some ways, technology has made the job search so much easier and so much more accessible, but at the same time, it's created some extra.
I'm Rich Filoni, Senior Strategy Reporter at Business Insider. I first heard about HireVue when I wrote about Unilever's experiment in hiring. Unilever is one of many large companies that is incorporating artificial intelligence into their recruitment efforts. HireVue uses video analysis to screen employees and rate them before a recruiter even gets to look at their interviews.
I'm Lauren Larson. I'm the Chief Technology Officer at HireVue. HireVue has a platform that simplifies the job interviewing process. The most common use of that is what we call an on-demand interview, where you create a set of questions that respond on video, and then we use artificial intelligence algorithms to evaluate their performance, and then we analyze the interview and predict their performance based on the interview.
So HireVue set up an application for me where it was 11 interview questions. I used my iPhone. The entire time I felt very awkward and very self-conscious because I was looking at a video of myself.
And then we made an analysis of the features that are important for that job and produced what we call an insight score, which is essentially his ranking compared to all of the other candidates that we've seen. Well, fortunately, Rich did really well in this interview.
Basically, what this is just doing is looking for things like eye contact, enthusiasm. If this is someone who's going to be working with clients face to face, do they smile, or are they downcast? Are they looking away from the camera? So some of my skepticism was averted when I actually saw how the product worked.
The machine is going to look at 25,000 different features and complex relationships between those. We might see things that I'm not able to see as a human.
AI in recruiting at this point is still basically in its infancy. I think what HireVue is doing is interesting.
Basically, what they're just trying to say is like, analytics can be used in human resources, like especially in AI recruitment. I think some of us would have made use of HireVue, I think specifically for interviews like maybe Bank of America, Merrill Lynch. Yeah, so basically you record yourself, and answering some specific questions, and like based on that, the AI platform, that AI platform will actually analyze several things. I think they said based on about 20 something thousand features, basically to look at, probably you're looking down, or maybe you're not smiling, just like we have not been smiling, like check so many things, maybe your gestures and how confident you are while talking. For example, for some roles that has to do with maybe client facing, they could see with this person, like, be able to make our clients, comfortable with also speak about, can this person convince clients, like is this person bold enough to convince a client and stuff like that. So it depends on the role and it depends on the company. So they specified some of all those criteria. Also, I think I've built like a CV ranking system before, where the platform is able to rank is able to rank candidates based on a lot of criteria, maybe based on the previous role, like probably the person is actually applying for a role that is related to what the person has been doing in the past, maybe the person's certificates or the professional certificate the person has, or maybe the educational background, maybe is related to the field is applying for, or maybe years of experience, like in form of natural language processing, basically. So some of all these things, they help a lot in human resources. Not only that, they can be used to predict, probably the staffs that are going to exit the company. I think they call that attrition. They are going to look at a lot of things, probably the past record of people who have been leaving the company, what's common amongst them and stuff like that. Also, this analytics can also be used in in almost any retail services, probably to segment customers. You'll be able to group your customers into different buckets. That, oh, these customers, maybe these are my loyal customers, these are maybe promising ones. You can't handle them the same way. I think they talk about maybe the 80-20 rule, Pareto rule. I think you have to focus on maybe the small percentage of your customers that will lead to maybe 80% of your revenue and stuff like that. Then it happens in bank too. It's not everybody that queues in the bank to pay money. They're able to know the kind of customers they have and the ones that they value the most and stuff like that. Then analytics can be used in almost mention any field. Probably when you're asking questions, I'll be able to delve into other areas. There are a lot of things to talk about, actually. So these are some of the skills that are required for data analytics. Like in one of the videos I showed, mathematics and statistics. So it actually depends on the role in particular. So some roles require more of mathematics and statistics than the other. So for example, things like maybe data scientists will actually need more of maths and stats. You need to know, or maybe machine learning, machine learning engineer, you need to know how some of all those models work and stuff like that. You need to understand the mathematics behind them for you to be able to build efficient models and models that that you can explain. But for some roles, like let's say data analyst, you might not need deep mathematics and statistics like that. For things like neural network, you need mathematics and statistics actually. Then your coding skills, I think, it also varies it also depends on the role. And each kind of language, the extent to which you use them depends on like the role too. For example, someone who is a research scientist or a machine learning engineer will most likely be tested on data structures and algorithm, maybe in Python or whatever coding language that is using. But someone who is like a business analyst or a data analyst might not be tested for data structures and algorithm. Maybe person will be tested for SQL, just maybe more of SQL, or maybe visualization. So it actually depends. Then data wrangling, I think that's very important for almost every data role. You must know how to, like prepare data, and data is not always coming in the formats that you need it, and you need to be able to, be able to wrangle it and prepare it in a way that is usable, whether for the visualization you want to build. For example, Tableau, for example, it has its own standard formats that, like it will be able to, it's a drag and drop tool. So like there's a way the data must look like before you can be able to start building your visualizations. Although I think they've created new, I think recently, maybe a few years ago, they created Tableau Prep basically for pre-processing data before moving it into the Tableau desktop. Then you have visualization. Like visualization is very key. Like I think that's what comes after almost all the technical part of, analytics. Like you must be able to, show something to your audience. People don't want to really, your customers or the C-level executives, the CEOs don't want to see the codes. They don't want to see the models. They want to see visualizations explaining how these insights can impact maybe the organization, or maybe how it can add revenue, or how they are going to generate this from this, or how they are going to maybe how it's going to optimize a particular process. They want to see it. They want to, and you also need to be able to communicate like that. Here goes the communication skills. It's not just about building data visualization. Like whatever visualization you are building, you must be able to communicate the results. You must be able to like tell a story about whatever insights or whatever patterns or whatever trends you saw after whatever analytics you did. So, and I think for different roles, the extent to which you do data visualization or you communicate results, it actually differs. And okay, I think it would be nice to mention that I think you should at least have an idea of almost everything, because like there are different data rules, and I think we switch a lot amongst like all the roles. For example, you might just want to, you might be doing more of data engineering today, like maybe in the next 2 years you want to try maybe BI developer and stuff like that. If it's something that you've been challenging yourself to, do some of the, like, to own some of the skills, like other data skills, it will be easier for you to transition, like, or to change your career. Like, it's not really a career change, like to just, take one of the nearest role. Then machine learning skills, like that's important for maybe data scientist, or maybe machine learning engineer, or maybe research scientist. You must be able to know how to use all these libraries, or maybe deep learning, TensorFlow, yeah, natural language processing. Yeah, knowing, you must also be able to write efficient codes, because you might be working with software developers. Basically, you'll be building APIs, you'll be testing your models, you'll be deploying them. Then real world projects, many of all these things, like, it's easier said, like to it's easier to learn them, like when you learn them online, like maybe via all these online courses, you think is that easy, but like I think it's good if you work on real life projects to actually have a feeling of what it is like, because real life project is actually different from all these online courses. You get to do a lot of research, and I think there's supposed to be research as part of the skills. You are going to learn a lot while working on a project. Every time you work on a project in analytics, you're going to learn a lot of things, and you must be able to know how to Google search. You must know how to find information about things that you need to solve a particular problem, maybe articles or papers, or blog posts about similar kind of problem, or maybe about the domain in which you are applying I think there's also supposed to be domain knowledge here too. It's not here. You must know about the domain to which you are applying that analytics problem to. For example, let's say you are trying to build visualization on let's say in finance or something like that. You must know about the key things, or the key metrics, or the KPIs when it comes to finance, or when it comes to accounting. Like, so when you are building your models, you know the whatever variable that is going to maybe improve your accuracy or the whatever evaluation metric you are using. Or even if you don't have much idea about it, I think you might need to work um, closely with maybe a domain expert. And that's where in the video I showed you earlier on, where the lady was talking about, having a lot of meetings, data science is actually a process on its own. I think you also have to consider it as a philosophy. Like, think about you must first plan how you're going to solve that problem, collect information, have meetings, before you actually start writing codes. You must think of so many things that could go wrong, refine your plan, like write a plan, come back to it, keep asking questions from different people, maybe domain experts. When you think of so many things that could go wrong, you'll find ways of solving those problems. Your goal might be modified to, again, maybe probably you see that you'll be able to know that these things that you thought were possible before are not possible again. You modify everything, you go back to the people that gave you the problem. Can we deliver it in form of something like this instead of this? Because this, probably
Wow.
you thought something. Yeah.
Yeah, so a quick one, please. We are running out of time now, so please could you just round up quickly? Thank you.
Yeah, sure.
Yeah.
I'm actually in the last slide. So, like, I think I've mentioned some of all these things before. So these are some of the roles and like the tools. These are some of the roles in analytics. I think there are many of them. There are actually a lot of variants, and some of them are like actually uh, intersecting. They do a lot of things in common. In fact, a particular for a particular role, the person might be doing like more than 3 different role jobs, like depending on the company. I think the company always overuse data professionals too. So data analysts, for example, like they're basically the one in charge of, you know, uncovering insights for a particular organization. They try to, dig out patterns and, yeah, basically they use R, they use Python, they use SQL, and some other tools apart from these 3. Yeah. Then also data engineers. Data engineers are basically the ones that make things easy for the data scientists and maybe data analysts, in the sense that they try to create like maybe pipelines for or make data available in a clean way or in a usable way. Maybe all this unstructured data or structured data coming in various forms. They try to bring all of them together and integrate them and make them readily available and always accessible and always like they always be on the fly available to the data scientists. Data scientists basically build models. Yeah, they build models. They do. In fact, I think their role is actually it's very comprehensive. Like they start from the beginning, like talking to the stakeholders involved on a project, doing a lot of meetings, knowing what the problem is about, uh, identifying like maybe the data they are going to use, collecting the data, cleaning it, sometimes depending on if the data engineer is available. Then probably they build sophisticated models, like maybe deep learning models, sometimes like complex models to solve problems, and they answer some of those business questions they've already gotten from the clients in the meetings and everything. Then the machine learning engineer, they do some of the things data engineers and data scientists do. It's just that like they are more concerned about making this thing when I say production ready, like basically building APIs, making, some of all these models that we build, they won't stay in our Jupyter notebooks or remain in Python like that. So basically the machine learning engineer they build efficient codes, they write APIs, they try to test some of all these codes, they deploy it and make it usable in form of like you can integrate it to a software or call some of all these APIs as a service. Then BI developers, they do something close to data analysts. Probably they write, like they try to do some form of business intelligence, maybe in form of maybe dashboards and stuff like that. They make use of SQL to query data from databases, and they always know how to do some form of ETL. I think BI developers, um, yeah, I think they work close. Okay. Then ETL developers, that is somehow close to data engineers' job, maybe just like doing some specific roles. I think ETL in particular is about, extracting data, transforming it, and, loading it into a particular warehouse where the data can be easily accessible by maybe a data analyst or a data scientist. I think it will basically be a subset of the work of a data engineer, because data engineers normally do ETL too. Yeah,
Okay.
so
All right. Thank you, Mr. Bisiga. Yeah. All right. That was quite an insightful session. Yeah, we really learned
yeah.
things quickly. Yeah. So yeah, we'll just take a couple of questions and then we'll end this session. Okay. So yeah, someone is asking here, that's what are the most important skills to learn for someone in HR that wants to transition to data analytics. Someone actually doing HR now that wants to transition to data analytics, what should they learn? What skills?
Well, I would say maybe let's say Excel and Power BI. I don't know, for a start. Basically, if you have data available about, maybe your employees, probably, for example, you just want to, yeah, maybe basically about your employees, you want to check things like maybe the engagement rate of staffs, how engaged are your staffs, like how you basically be building dashboards that could give you informations, when it comes to hiring. Like, for example, you want to analyze things around maybe staffs that have been, entering, that have been coming into the firm and have been leaving. You want to see, what has been the cause of, the high exit rates, like the high attrition rates, dashboard, like very good dashboards can be useful in that case. And I think maybe learning a Power BI or a Tableau. I think those two are um, they're actually they're actually at the top when it comes to the visualization tools. They are easy to learn because they are drag and drop. I think Tableau is easier than Power BI. I've been using Tableau of recent, but I started with Power BI. Then you could also use some of these scripting tools too for visualization. I don't know, R and Python, but if you're just starting, maybe Power BI or Tableau. Then maybe Excel too can be very useful. All these charts, basic charts, maybe some basic analysis on Excel too can be very helpful when it comes to analyzing, data about your staffs and, yeah,
All
about your
right.
people.
All right, sir. Thank you so much for the answer. Thank you. It's really great. Thank you. Okay, so yeah, we'll just take two other questions and then we'll end the session. Okay, yeah. So there's a part you actually skipped, which is very, very important. I want to go into a particular sector as a beginner or a field. I should know at least the cash, now income. What do I stand to get? Like in all of this field, it's obvious. Most people always don't want to talk about salary range and all of those things. So could you just share more light on that? Like what are the salary expectations for a data scientist or a data analyst or a data engineer or whatever? So far you're in data space, because yourself now is reflecting that you're fresh. And I mean, so let me also get to know what is in that space. Like if they're actually investing money, let me quickly jump in. So could you just shed more light on it? Thank you. Quickly.
Yeah, so firstly, I'm a student, so I'm not fresh because of I'm chopping money in analytics. So, like, maybe I don't know too much about the salaries, like the exact figures, but I think I'm going to say research scientists, they earn the most. I think they earn more money than software developers or software engineers, actually. Yeah, I think research scientists, and it's actually more intense. like you're going to basically be, like the word sounds, research. You're going to be like maybe writing new algorithms for new machine learning algorithms, or algorithms basically. So if you want to get in for a research scientist role, you more probably be tested for analytics, like machine learning engineering, like skills, and you also be tested for software development skills, like how to build a complete software or something like that, and maybe all these data structures and algorithm. Then maybe I think data scientists earn the most after research scientists, yeah, or maybe data engineer. But I think now, like data engineer and data scientists, I think they are going to we're going to have more of analytics engineer now, like because analytics engineering is just like an intersection between data engineering and data science, and I expect that the money they pay from there will be more, like because it's an intersection of both roles. Then I think machine learning engineers too, yes, machine learning engineers get more, if not more, than data scientists, because like they interface with software engineers, and they do something close to what research scientists do. Yeah. Then, yeah, I think my eyes is actually on when it comes to pay. My eyes are on research scientists and software engineering combined with ML. Recently, I applied for a role that combines um, ML engineering and software engineering role. So my eyes are on those two roles in particular. They pay a lot. I don't know if I answered your question. I don't really know much about. I'm always aiming for the highest paid. I don't know about the other roles like that. How much they pay? Hello, can you hear me?
Yeah, I can. All right, thank you so much. Thank you. Although you're not specific, I was expecting an exact figure, but nonetheless, it's fine. Yeah,
No.
so okay, yeah. So quickly to wrap this session up. So just one word for a beginner. Like I want you to summarize everything you've taught us today, like just in one sentence, like a beginner that wants to get into that space, like I want to go into data analytics or data science. What would you say? Like how should my learning curve be? Like just in one word or a sentence, just summarize everything. What should I watch out for? What should I do early? What should I learn early? Can you just put that together and let's have it? Thank you.
Yes, my own part was rough actually, Sha, but I would say like you must have this intellectual curiosity, like to always learn new things, because look at all the tools that I mentioned here. These are just 5% or 10% of the tools that are like actually needed. These are just the top ones. So there are a lot of things to learn, and you have to just start. You just have to start, and you must, keep learning, and the thing is changing. Like before, and nobody was really like no one was putting attention into, like putting a lot of attention into like analytics engineering, but now it's looking like something that is trending. So like things change a lot when it comes to the data field, and you must be able to adapt quickly, because your expectations, like when you learn some skill sets and apply for a role, and you eventually get in, you realize that they start telling you to do some of the things that is not specified in the role, like before applying, or they'll start telling you to do other things. So you must, like, even some of the things you do in the online courses, like you end up finding out that you don't know anything like that. When you start working on real life projects, you have to start learning afresh again. So you must be able to, like, you must be strong, and you must be able to learn things fast. Yes, I think those things are very important. Yeah, i've had to like I've had to like learn a lot of stuff like that I didn't know about when working on projects, researching on, making use of past people's project and adapting it to my own, and yeah.
Okay, okay. Well, thank you so much. I've gotten something. Okay, yeah. So yeah, thank you, Mr. Bisiga. That was quite an insightful session and a wonderful presentation, I must say. Yeah. So thank you. We'll just take a closing note. So guys, we'll just take a closing note from Arizi, and then afterwards, I will just tell you what you should do after this session. You could go your social media and do just read about us, write about us, what you learned today, and then hashtag TechSemester.com. Okay, yeah. So thank you. Arinze, just tell us one or two things before we end this session. Thank you.
Thank you very much, Avisiga. That was really like an insightful session, and I indeed did learn a lot. I think now I also want to abandon my role and start pursuing machine learning engineering or research scientist role, so we can all be at that top. But yeah, I mean, discovering new roles in the data space and also learning how to to any of those roles. That has been very insightful. Thank you very much for the session. Thank you very much, Abisiga.
You're
All
welcome.
right. As you all know, today marks like the sixth session, which brings the Getting Tech 1.0 session to an end. We do hope you got a lot of value. Can I see like reactions? Was the session value for you? I'd like to get feedback very quickly about the session. Like anybody, let me just take two people quickly. How's the whole session been so far? And since Abisika is here, like, do you have any feedback for him? Like, you can just give that. So yeah, you can use the raise hand feature if you'd like to share. Or if first you like to just go ahead on mute and share directly. I'm waiting. Anybody?
Yes, something I want to mention. Yeah, so don't be scared of when you start learning analytics, like any whatever role, yeah, you start learning the skills like for analytics and you want to start applying for jobs. Don't be scared about the job specification or the tools they require you to like learn, because those things can be scary. I don't know if anyone can hear me. What's this thing now? Hello?
Yeah, I can hear
Uh,
you, sir. I can hear you, sir.
okay.
Yeah, go
Yeah,
ahead.
just apply. Like once you know some of those things to some extent, just apply. Like don't be scared, because some of all those job roles can be scary. Like you see one person, when it's not a team they're asking for, you must know this, you must know that, you must know, like data science is very wide. I mean data analysis is very wide. So some of this, human resource or people like that creates those job specifications, they just check online for the best possible set of tools, and they might not need everything, they might just need a subset of it, and they just make people scared and stuff like that. Just apply and don't be scared. That's what I would say.
Just apply and don't be scared. Yeah, thank you very much for that information, Abisiga. Yeah,
Yeah.
thank you. Yeah, we're rounding up the GIT 1.0 session. I want to know, Ogechi, is there any review you'd like to share? How's the session been so far? Emmanuel, how's the session been so far? Larry, yeah, okay, Larry, go ahead. Your hand is like raised up.
Um, Thank you very much. I'm Lanre Akorede. I I'm not a millennial. I'm about 47 years old. I listen to you guys. I've learned a lot from you. Honestly, I can't tell how you've been amazing in your presentation. Talking about the back end, the front end. I'm actually old school, really, but I tell you, you've imparted so much knowledge in me. I'm actually listening from US, just like Majid Avishiga. I am in Chicago. I have about 15 years experience in HR, and
Wow.
also I actually finished from University of Lagos in the year 1999. I read psychology. I'm also a nurse at the same time. I'm a nurse right
Wow.
now. But I've learned so much from you guys. I appreciate you. I hope I can network with all of you with time. It's my pleasure. I love it, and I appreciate you guys. Testimony, you're wonderful. Rinze,
Isaac, everybody, you guys are great. Thank you for bringing this together, and thank you for doing this wonderful job. It's so great. Thank you, and thank you.
Thanks so much, Mr. Larry.
Testimony, come and catch us up. Thank you very much, Larry. Thank you very much for that feedback. That was very helpful. Yeah, we're looking forward to organizing GIT 2.0 next month, or say the month after. We are hoping to make it better. So any other person with the review, also what you think we can do better? Larry, what do you think we could do better, sir? How could we better organize the sessions?
No,
Help about 1,000 people per session, and maybe that number increases as we continue to roll. Transition is yeah.
I think the fewer the merrier. Really, it's so great. Honestly, you've done a great job. If I look at the post training evaluation is superb. All your faculty, they are very very sound. Honestly, I won't lie to you. I join online training almost every time. This is one of the most amazing Zoom training. Well, just you guys are young, but you have so much resources. You have so much knowledge. I tell you, keep it up. You are doing great. Don't let anybody bring you down. You are doing the right thing. Trust me.
Again, testimony and Isaac, come and catch your stuffs here. So yeah, thank you very much, Larry. That's really helpful. Like that feedback like this is very helpful, and we hope to do more and serve the government community in better ways. Thank you very much, Larry. Thank you very much. So yeah, thank you very much. Again, I cannot emphasize how helpful the feedback was or is or will be as we go ahead to make further decisions in the future as regards whether or not to make the session
one more thing. Maybe going forward, you could probably invite somebody with a soft skill. You're talking about data, IT. People run all these initiatives. I'm like a people process and policy specialist. So you need someone to the soft side of it. So after your training, talking about the front end, back end, I love that. Data science. You need someone to come up on board and teach us the soft side of the whole thing too, just to cap it up with the soft skills training.
Yeah, that's very correct. If you also notice, we had just 6 sessions here. That means we were unable to cover all of the different areas that we would have loved to. So in GIT 2.0, we are hoping to expand the scope and bring in more faculties. Maybe we would also keep in touch with you, Mr. Lanry, to see how you can help anchor the session on soft skills, how to help these technical talents see how that soft skills is very important. Even Mr. Bisiga during his presentation mentioned how that communication is very important. And I'm very sure beyond communication that many other soft skills have helped Abisiga thrive in his career in data that he possibly did not put in the slides. So yeah, all of those soft skills are very important, and we are looking to incorporate that in the GIT session 2.0. GIT program 2.0 rather. So yeah, I don't know if you could leave your mail to testimony, maybe private chat, and we would be in touch. Thank you very much. So yeah, I'm glad to bring the session to a close because I see we are taking your time, and we always ensure to keep time. But because it's the last session, there's a feedback form that we usually send at the end of each session. We do have certificates of completion. Typically, we wanted to give out the certificates at the end of the second edition, but we just thought to give it out to people who have been consistent filling out the feedback forms that testimony has been putting out at the end of each session. So if you've been filling out those forms, we have your mails, we'll be in touch with you, check your inbox, and we'd forward you certificate of completion for participating in the Get Into Tech program. And we hope that will be helpful maybe today, tomorrow, or somewhere in the future. Aside that, we also have this program we are putting together. We're yet to bring it to we're yet to have conclusion on how it will go or when it's going to start running. And we've tagged that the group pipeline. So the group pipeline is also help people. The GIT program helps you make a decision as to which career path suits you best, right? And we trust that many of you have already deciding on which career paths you'd like to pursue. So yeah, if you are settling for data analytics or software engineering, front end, the back end, or product management, or either of those roles, UI, UX, graphics design, the growth pipeline is supposed to be some form of accountability program that helps you see through your learning program. It's all free as well, and mostly coordinated by volunteers. So if you have volunteer also on the session, that's where you'll be more active. You'd be accountable for people's growth as they learn a particular one tech skill or the other as they have chosen. So the group pipeline will be announced to you. If you fill the form for the Get to This Tech session, we'll be in touch with you. If you not feel that, you could ask testimony for the link and get yourself registered properly so we can easily account for you and your growth in the tech space. Then there's also something called the starter pack. It's a folder, a document that has a link to a number of free resources that we've been able to pull together. Our thanks testimony, and we have those free resources pulled together in a single document. That means if you have chosen to start a career in front-end development or back-end development or UI, UX, data analytics, and what have you, that document has a link to resources, free courses, articles, videos that you can watch in order to grow. So you grab your starter pack at the end of the feedback form. So ensure to fill in the feedback form. And yeah, just at the end of testimony, get testimony on myself. Anybody would get the starter pack across to you. Yeah, so finally, there's an official announcement for GIT 2.0. We hope to be able to do this, say, 4 times every year, or 6 times every year, or 12 times every year. How many times we do it? I want to help as many people transition in tech space as possible. So for GIT 2.0, we possibly will be having a MOOC, a massively open online course. So we aggregate a lot of free resources, videos, or pre-recorded content. And then the live sessions will now have an esteemed faculty come around, walk you through that part. Even though you've had other materials to consume before the class, they'll still walk you through that like over 30 minutes, but more time will be dedicated to questions and answers. And that's what makes 2.0 much more exciting. We are hoping that you are able to invite and then put out the links for registration. We're hoping that you reach out to your networks and invite them to also participate. So yeah, GIT 2.0 is coming up sometime in April. This March, April or May, most likely April. But yeah, it's coming up, and then it's going to be much more exciting, a lot more packed, and yeah, it's going to cover much more fields. Yeah, most likely we'll have Larry leading us on soft skills, most likely. Yeah. And other fields as well beyond the ones we were able to cover in GIT 1.0. So yeah, that's it from me. I'll hand over to testimony to just bring the session to a close. Thank you very much, everybody.
Thank you so much, everyone, for joining. I hope you had an amazing time. Apart from the feedback form that you'd be filling, we'd also like to hear from you across different social media platforms. So you can just tag us TechSemester on Twitter and on LinkedIn. So yes, we hope to see you at the top. Enjoy the rest of your evening. Bye for now.